So I'll talk today about conversational bots with focus on customer care. I think the motivation is already very clear to all of us. So if we look at the predictions, it says that 80% of the businesses, they want virtual agent conversation. Okay, I will use either virtual agents, bots, conversational bots. They are all the same for me in this talk. And also that 85 of the companies, they want customer service to be powered by a virtual agent by 2020. So it's all good. We all want it. It's actually mainly due to the advancement in the AI and NLP. Also due to the very common messaging coming actually from the social media, but getting so we are all getting used to this kind of interaction. And also we see the benefits, it's quite clear. It's always on, we can reduce the cost of the services, personalization, scalability, and so on and so forth. So I hope motivation is now even more clear. So in the talk, I will actually go on two work that we did, but let me start with some introduction about affect. So I'm not a psychologist, computer scientist, but some of our work, we are working with psychology, and one of the issues is about affect. So affect has actually three different stages. It's called personality, mood, and emotion. Personality basically is something that we said we're born with. So it's something very static, stable. Usually you don't change your personality. And on the other side, we have emotion, which are very dynamic, and they usually happen or occur due to some event that happened. They are very momentary. And we have mood that I will ignore in this talk. So in the personality, and later on I'll explain again, we have different measures or different ways to define it. There is one famous model called OCEAN. It's for openness, conscientiousness, extraversion, agreeableness, neuroticism. And we have a list of emotions that goes actually beyond. I said it for customer care, and we are going beyond what we call the basic emotions. So we are looking also frustration, confusion, which are quite common in customer service interactions. Now?
אני מתקשר רגע למי שאמור להיות.
עכשיו?
אני חושב שזה ברמקול ולא במיקרופון.
במערכת הגברה, אני שנייה...
אפשר בלי?
אז לא יהיה הקלטה, כי ההקלטה מחוברת לזה, אז חייבים את המיקרופון. אז שנייה, אני אבדוק מה אפשר לעשות.
שאלות? זה בסדר?
ננסה להמשיך, אני אקרא לו.
אוקיי. אז הדבר הראשון שאני רוצה להזכיר זה, first thing is about affecting customer support. So it is very important. You can see the image here. Actually, you cannot see, but it says customers bring two things to the call. This is the problem, and this is the emotion. And if you look on yourself, this is when you try to contact or call center or something like that. Usually, it's getting very emotional. And again, researchers from psychology, they already know that there is a correlation between the emotion that is maintained during the interaction or the conversation and the output. And especially there is a focus on negative emotions. So those are more meaningful towards, so the effect of such negative emotion is very critical. Also, it's good to have positive emotion, but it's less important rather than the negative emotions. So the idea is we want to be able to use all this emotion during the interaction. The other side is the conversational bot or the virtual agent. So we believe that any agent should have this layer of being able to detect and to behave, change the behavior due to the emotion that it's sensing. Also, when we as humans interact, although we are interacting with bots, because we are used to interact with people, then even that we know that it's a bot, we still behave like it's a human. So this is, maybe we are the last generation to have this kind of interaction behavior, because the next generation will be interact differently, but at least for us it still holds. So this is also very important to have the bot being able to be adaptive to this layer of effect. Okay, last comment. So already, there is a company called MetaSite. They are doing customer care over the phone, and one of their patents or the claim. Anyway, what they are doing, they maintain a personality profile for each one of the customers, and they have their agent available. And when there is a call, they know who is calling, and based on the personality of the person who called, they pick the optimized agent to have the conversation with. Because the idea is that not different, but some interaction between personalities can benefit the call. Okay, so the first work I'll talk about it is about personality. It's called Neural Response Generation for Customer Service based on personality traits. It was achieved the Best Short Paper Award last year in INLG. So I think the motivation is already here. Conversational bots are everywhere, customer service, mobile apps, robots, and so on. Also, it would be very good if we can adapt the bot, as I mentioned, to be able to behave differently based on the interaction, the application, the brand, the culture. So you can think about different brands. When you think of them, they carry with them different ideas. So we also want this to be propagated to our bot. So I mentioned the personality traits. It's a set of traits that are durable. We are using the Ocean model, which is basically usually you get it. You do some questionnaires. So you get a questionnaire, they ask you how you feel about that, how you feel about this. They have lots of questions, and at the end they can say, what is your personality? When we talk about customer care, there are two of the traits are important, the agreeableness and the conscientiousness. I'll just read what is the agreeableness. Is the person's tendency to be compassionate and cooperative towards others. And the conscientiousness is a person's tendency to act in an organized or thoughtful way. So the idea is that we want to be able to generate a response for the bot that encoded in itself some personality traits. And in order to do this, we're using a sequence-to-sequence model. Okay, so here's an example. So we have a customer saying, why isn't your service working? And now we can see two answers or response. One, we call it a consensus agent. This is a regular agent that we didn't apply any of the personality into it. And then you can see the responses, we are aware of the issue and are working to fix it. Then we have our agreeableness agent that answers to the same utterance by, we are here to help, are you getting any error message or codes? Clearly, you can see that there is a difference between the two answers, although they targeting the same customer utterance. This is another example, and this is actually what our sequence-to-sequence generated. And later on, I'll explain how we did it. Another example, we are here looking on conscientiousness, and again, if you read the example, you can see that there is a clear difference between the two responses. Okay, I'll just mention some related work because it's important. The first work that actually argue about the connection between the linguistic and the personality is done in 2007 in AT&T Lab. And what they did back then is they actually extracted features that that they found important. For example, if you are more neurotic, then you use shorter words, or you use more verbs or pronouns and so on. So they have some features that they defined, and then they have some. They learn how for each personality how much you need to weight each one of the features. The other work that was done recently is it's called a persona-based, and their idea is quite similar. The idea is that they took, for example, the IMDb. They took the Big Bang Theory. You all know this series. They took Sheldon. So basically, they study each one of the persons. So you aggregate to take all their part when they are talking, and basically they learn how to speak in a Sheldonic way. Okay, so and this is, you can understand it's a little bit more than only the personality, because it can encode itself maybe the country. So he's from Texas, so maybe use different words. So it's idea. It's what we call abstract persona that they capture. Okay, so now given this, what we did is that basically we used a very simple LSTM encoder and attention-based LSTM decoder. So this is the regular one. What we did is that we had another layer. So during training time, what we did, we have pairs of customer utterance and then agent response. But we also know the agent personality. So during learning time, what we actually learn is another layer that we call hidden layer, the HP personality, and we actually studied the parameters for the tuning. So what happened that in test time, we can actually decide, so we can give different personality traits, different weights, and based on the personality that we want to create, it will go to the hidden layer, and we'll choose the right or the best terms to use. So this is how we extended the LSTM, adding another layer of personality. Okay, so to test train, we used, there is a data set of 1 million conversations of 62 different companies. What we did is, first we did some filtering, because we need agents that have enough data, because we need to create their personalities. So after filtering, we have around 90,000 pairs of customer agents inputs. Okay, questions? Okay, so in our data, the agent is a human. So the data is coming from Twitter conversation, but also for human, we know that there are different traits. So the idea is that, I'll talk about it now. The idea is that I told you that if you want to infer your personality, you have to go do some questionnaires, but actually I lied a little bit because there are already some tools that can take enough text that you wrote, and based on the text that you wrote, to generate your personality. And basically, there is a tool that we use by IBM. It's called Personality Insight. It was trained on blogs and tweets. So you give, I think they're famous is for Barack Obama, and every year you try to take all the tweets of the police, I don't know, whatever you want, and you generate the personality. So we did the same for the human agent in our training data. Okay. No, okay. So, someone said that the support in Twitter, or you think that the support in Twitter is done by different agents, which is correct. But what is nice is that the agent need to add some kind of signature at the end of each tweet. Because, so you can see some text and then you see some, I don't know, some tag and it says some initials. And the idea is that those agents, later on they need to show what they did. So lucky for us, all the companies, and you see 62, so it's something very systematically. So it helps us, of course, yeah, it's a good point. Okay, so now we have two settings. So we start what we call a warm start. Warm start, this is a regular setting when we take all the data that we have. We have 80 for training, 10 for dev, and 10 for test, the regular setting. And we compare ourselves to regular sequence to sequence, the persona-based, the abstract persona, and ours. And we look on two metrics, the perplexity and bloom. Those are common in text generation. The lower perplexity is the higher quality, and the higher blue is the higher quality. So you see that this is our model. We are doing better than sequence to sequence. However, we are doing a little bit worse than the persona, which is actually not that surprising, because if you recall, we are only looking on the personality, and in their approach, they are having this abstract persona, which can capture much more than the personality. But when we go to a cold start is a different setting. When we keep the test data as new agents, so those are actually agents that we never saw. And basically, if you can think of it, we can generate, by our approach, any agent with any personality. So if the persona, they need to know the data, in our case, we don't need to know. So it means if you go back to the interaction of MetaSite, they have a pool of real agents with some fixed personality. But in our case, we can actually generate, while we know who is the customer, we can generate a really optimized one, optimized agent to deal with this customer. So here, of course, we cannot compare ourselves to the persona because they don't know how to, they cannot do it. And still you can see our improvement much more than the sequence to sequence. Of course, that it's not, yes?
Talking about optimization here, if your objective is to fit the real agent and not the business optimization?
No, okay, so the business optimization is always there. But even if we have the same business optimization, when you are into us, let's say I'm the virtual agent. when you are interacting with me and when she's interacting with me, I can behave differently because your personality and her personality is different. And it might be better that I'll be, let's say, more aggressive with you rather than with her. So this is what I think.
Might be bad for business. Your reaction.
No, so it's constrained on the business as well. So
How do you predict this?
okay, let me. I'll comment about this and business aspects. Okay, so quickly, let's go. So it's not enough to do these metrics, the blue perplexity. We also ask people, like I show you the example in early on. We gave the crowd some example from our data set that we generated. Basically, we gave them a customer and then two random answers, randomly ordered. The idea is that one of the agents has a high trait of agreeableness and the other one has a low trait of agreeableness. All the other traits are 0.5. So each trait is between 0 to 1. So one is with high, all the traits are equal. One has, let's say, the first one, high agreeableness, 0.9, and the other one has 0.1 in agreeableness. And then we show them the results and we ask them which one is more agreeableness in this case and so on. And basically, they were able to detect different responses with different traits. Okay, so that's what we show. I just want, before going on, I want to comment about how business goes on. So, as much as I know, none of the commercial companies, including Google, Microsoft, IBM, and all the companies are using generation, sequence-to-sequence generation. There are a lot of risks in doing it, and even today when we're using different approaches, as you will see now, the situation is quite bad. Yeah, it's a research, basically. Some showing some possibilities. Okay, and so I'll quickly go. So yeah, it was a little bit maybe theoretically futuristic, but we also have to work on some real problems with current systems. And the other work that I'll present is talking about detecting egregious conversation in customer interaction between customer and virtual agent. It was also presented into the North American ACI chapter. So what is egregious? Egregious is means outstandingly bad. It's the worst of the worst that you can imagine yourself. And what we aim is to actually try to detect those really bad conversations. So the motivation still holds from the beginning, but now when we look on what current virtual agents, how they behave, we can see that they might behave really bad. Even if they are, not using LSTM, they are coded in a more fashion. Okay. They might still behave really bad that can actually lead to some loss in customer loyalty. So I'll give you 1 minute if you can go through. This is a real conversation, anonymized to some extent that happened. If you don't see, I can read it. Okay, the customer, I got 2 quotes for the flight ticket, but I'm wondering what the details of each ticket are. The agent said, please select buy next to the ticket you'd like to purchase. No, I don't want to buy yet till I know the details of the flight. The agent, if you are in the process of returning the car, please continue by clicking next. Are you a real person? I'm a digital assistant. I've been trained to answer questions about travel. Ask me any question you want. I asked a specific question and you gave me a random answer about car rental, which I'm not interested in. I'm not trained on that yet, but I'm still learning. You might want to rephrase your question and try again. This service is pointless. Can I talk to a live person? We don't currently have live agent to check with online. Okay, so this is how today the quality of some bots can go. And this is what we are aiming to detect those very bad calls. Okay, so what we did, we extracted data from two companies. It's different two companies, different business logic, around 10,000 conversations. One of the company has, you see, much longer conversation, 8.4 times than the other one. And what we did, we treat this problem as a binary classification problem. We have two classes, the egregious and the non-egregious. We do the classification at the end of the conversation, so it's not real time, this approach. And basically we extract three sets of features. Features coming from the agent, from the customer, and the interaction between the customer and the agents. Also, a feature can be contextual. I'll explain about it. Okay, I'll just go quickly on a few features. So, yes. I'll explain about the labeling. Okay, here you see some feature like repeating response analysis. Okay, we want to detect whenever there is repeating agent response. Of course, the response is not identical, so we use some similarity between the word embeddings of the agent. And you see, it can be contextual. Why? Because it might be okay if the agent responds the same in the beginning at the end, but maybe it's not very good if it responds sequentially, the same answer again and again. So it has some meaningful context. From the customer, so we have four types of features. We have emotional analysis. Okay, we are back to emotional, as I mentioned, and we want to able to capture them. So we did a lot of work on emotion detection maybe 4 years ago already, so it's not that interesting anymore for us. We just use it in different way. For example, we want to find like peaks of emotions, of negative emotions, and so on. We're looking on rephrasing analysis from the customer side. We're looking also on, when you ask for a human agent, basically you can ask for a human agent, it's perfectly fine, but it's not okay in some cases. For example, when you ask with a very negative sentiment, then it might lead to an egregious conversation, so we need to capture those. And I'll point maybe some of the customer agents. Okay, so this is a nice example. We call it long sentences by the customer, and then agent response of I'm not trained on that. So just you imagine yourself, and I saw a lot of blogs, people actually writing and writing and writing in one of this. They try to maybe explain something. And they put a lot of efforts in writing all the things. And after they press click, in a few seconds, they have, I'm not trained on that. Which is actually a problem because when people write very long sentences, it's very difficult to detect what are the intents. And then usually the bot doesn't know how to deal with it. But from the customer side, it actually leads to some frustrations. It can go on to an egregious conversation. Okay, so for the data, so we sampled around 1,000 conversations, and then from company A and another 200 from company B, and we used 4 expert HCI experts for this task. We didn't go to the regular crowd. The data was sensitive, and we needed some HCI experts. This is what we asked them to do. Conversations which are extraordinarily bad in some way, those conversations where you'd like to see a human jump in and save the conversation. So this is the only explanation they got, and then the conversation to tag. You see that the iterator reliability was quite high, 0.72. This is a difficult task, and that's why we needed a human expert for this task. Okay, so around 8% of the conversation were egregious, which tell us that we have a small class which is difficult to detect, rather than non-egregious one. And we compare ourselves to two baselines. One is text-based. Basically, we just analyze the text using, unigram, bigrams, NLC, this is for emotions, and all the other stuff. And also we have some rule-based, which capture some behavior of I'm not trained on that, or if the customer is asking for a human agent. And we use a simple classifier, SVM, to... Okay, quickly on the results. Recall that we are interested in the egregious results. We analyzed the precision, recall, and the F1 measure. So you can see that this is our egregious classifier. You can see that the text space is actually not quite bad. In the precision means that in the text itself there is something that encoded about egregious. However, you can see that the recall is much lower for the text, and we did in the F1 score much better. If we look on a different analysis, here what we try to do is add and see what is the contribution of each one of the feature sets. So we start with the agent, and then we add the customer, and then we add the customer-agent interaction. And you can see here that when we look on how the quality improved, that actually the customer features are the most informative one, because you see they're getting us the better improvements. Then we tried, so remember we have two companies, we did some cross-domain to see how robust is our model. So we did the training on company A, and we did the testing on company B. If we look now on the text base, so the rule base is really low quality, but if you look on the text base, you see that the quality is again now much worse than our. And again, you can imagine that there is something with company A and company B, two different companies from two different sections. So there is no connection between the data or the domain, and thus there is, in the text itself, it's not a good predictor anymore. And you can see that although we had some degradation around 10%, still the quality is acceptable. Last analysis that we did is about the customer rephrasing analysis. So previously it was suggested that there are some reasons why customers are rephrasing. And there are three main reasons. One, it's due to NLU. So the language understanding, there is a problem from the bot itself. So the customer need to rephrase again, trying to put it in a different way. Maybe this time it will have a laugh. The other problem is language generation limitation. So here I mean, let's say that I ask, for example, I want to know the rate of something very specific, and maybe the bot, it doesn't have the answer, it has a more general answer. So it detects that it's on this intent of, I don't know, getting some rate, but it doesn't return the exact response that I were expected to. And the last problem is unsupported intent, or what we called before not trained. So the system doesn't know how to handle those intents. And now we did an analysis to see how compared the three reasons in the egregious versus the non-egregious one. And so what we learned from this is that people are less tolerant to unsupported intent. So it should be clear to them what the agent knows to answer and what not. And on the other hand, we see that for language generation limitation, there are more tolerance. And not very surprisingly, the NLU error is the same because it's the same system. So we expect the same quality of natural language understanding for both classes. Okay, so hopefully I convinced you that we are able to detect those egregious conversations. We show that features are robust and we can apply them in different domains. We're looking on other problems now on real-time detection. We're collecting more data and do some log analysis.